When Aurelio asked me to do a talk, one of the things that I think about is uh, what's the kind of talk that people would like to see? Yes, I'm a UFO investigator. Yes, I'm a photo and video analyst for the Mutual UFO Network, and yes, I've had a lot of weird experiences, as many of you watching have had. So the point being, there has to be some type of interest that astronomy could impart to all of you. And for me, it goes like this. If there's an alien species that's been watching us from afar, if there's an alien species that is here already, which I don't actually say, I'm a science guy and I shouldn't say this, uh, if it's possible that there might be an alien species that's here, then we should have evidence. We should be able to see what's out there. Well, we know some. I mean, we have hundreds of thousands of cases in the Mutual UFO Network database. And some of these are just, birds and that are blurred, okay, whatever. But there is a certain percentage that aren't. But today's talk, we're going to talk about astronomy and the things that relate to astronomy. And then I'm going to give you, yes, you, act now, and you get free. And many of these are free. Applications you can download for your phones, whether Android or iPhone, that will give you the armament to be able to figure out what you're looking at as well. See, that's the golden nugget to give you something that you can walk away from. That's what I'm doing today. But first, we're going to talk about a little of astronomy. When we look up in the night sky, we basically see a lot of cool stuff in the night sky. And, we also see stars in the sky, of course. Well, stars are an amazing object that will often get accused of being an unidentified flying object. And I received many photos of stars on the horizon, and when they're on the horizon, because they're always ever points of light, they look big to your eye, but they're actually tiny points of light, ever so small. And you can't even see the disk of a star because it's so far away. You see the disk of the sun because it's close by. It's only 93 million miles away. And at light speed, it takes the light leaving the surface of the sun 8 minutes to get to here from the sun. And light moves faster than anything else in the universe. It's the fastest thing. It's the speed limit of the universe is light speed. So clearly, there is a long distance between here and the sun. But for other stars, they're even further. And not only that, the nearest star, the light still takes just over 4 years. Years, that's right, years to get here. And that's, of course, the Alpha Centauri star system, where, by the way, we found 2 planets around one of the 3 stars in that system. There's 2 that orbit each other, and then there's one on the outside orbiting those 2. And around that one out there's 2 planets orbiting that one. So we found that, and that's kind of cool. Now, as an astronomer, I focus on exoplanets, and that is planets around other stars. And the reason I do is because I think it's very important to study distant stars, planetary systems, to understand and logically conclude that life in the universe is the rule, not the exception. And that is the premise of the book I wrote called The Populated Universe. And this premise is something that I think is well-founded throughout scientific literature. No one can say, oh, there's no life elsewhere anymore. They used to. But now they say, no, we think there's life elsewhere. But then they say, well, we don't know if it can be intelligent. We don't think it can be intelligent life. Well, that's not really fair either, because we do think that life can be intelligent. So I think that's pretty interesting. So now, when we look at the stars up in the sky, one of the first things we notice is that they're different colors. Well, that different color means a certain thing. And when we look at let's pick on a constellation that's near and dear to us, okay? And that constellation is the constellation of Orion, okay? When we look in Orion, and I don't know if you can see my cursor. I really hope you can. But this is Orion here. But this particular chart that we're looking at here shows us that we have stars that go right down the middle here, in the middle of the diagram. You see the sun is right in the middle there, and then it goes down to red. Stars go from hottest and bluest to coolest and reddest. And this little line you see down the center of the diagram that sort of snakes down to the bottom, that continuous line of the smaller stars, That we call it the main sequence. Those are where the stars are that are normal. Normal stars can host life to some capacity. And normal stars from about the A type, which is down the bottom of the view here, from the A type over to the M, these are where the seats of life can begin. All right. If we're talking about the O stars and the B stars, O stars are the hottest and the bluest. And most of the light they give off is not visible to your eye. It's in the ultraviolet, which is high energy, very, very blue, beyond the blue end of the spectrum you can see with your eyes. And that blue light in the ultraviolet, that is, well, that's detrimental to life, to put it simply. It's life destructive, to put it more succinctly. And so O-type stars, they won't have any planets around them anyway, because a planet around an O star would be exceedingly rare, and we've never found one. And the reason is because of the fact that these stars are so big, they actually only only survive, exist for a few million years. They're so big, but they're converting hydrogen to helium at a prodigious, furious rate in their cores. So these O stars up here, we can't expect that these O stars would ever have a planetary system, because planetary systems take billions of years overall to form into a stable system. You know, the B stars are much the same. Okay, B stars don't have a stable system either. And you look down the bottom, you see this O, B, A, F, G, K, M. That's our, what we call our spectral class. And up the left side, we see by brightness. You can see where one is, the one in the middle of the, just below center, where it says luminosity, there's an L, and just to the right of it says 1. That's the sun. If you go to the right, you see the sun. If you go down, you see a G. So we're a G-type star, and we are the scales unity value, the 1. Okay, stars that are brighter are much more bright than the sun by up to several, hundreds of thousands to 1,000,000 times brighter than the sun. There's no chance your eyes would survive anything above 100 here. So it's really, these are bright stars. If you were nearby, even sunglasses probably would not work, because most of the light getting to you would be in the ultraviolet. So anyway, further from that, they're cooler and they're redder and many times smaller than the sun in mass and in radius and size. It's amazing. This diagram we call the Hertz-Sprung-Russell diagram, but don't worry about the name. What it really means to signify is that we look at stars and we have a classification scheme for them. That's all. And this is it. Now, above these stars, you also see these other ones here, these brighter, bigger balls. Okay, we got the red ones, the yellow ones, and the blue ones again, and even bigger ones beyond that, these two big red ones here. What are those? Well, when a star finishes normal hydrogen fusion, like here on this location, right, in the main sequence that we see down below, then they turn off that main sequence, and they kind of go off the main sequence because they start fusing something else. When all the hydrogen is gone and all that's left is the helium, well, when the hydrogen's gone, the star begins to contract. And that does two things. That brings more hydrogen down toward the core, where the only fusion takes place in a star. It doesn't take place in that gigantic ball that you see in the sky. It's at the very center of that where it takes place. Okay, and that's it. But as the star contracts, it's getting hotter and the pressure is increasing in there. And when it gets to a certain temperature, once again, then the helium that was previously created by the hydrogen to helium fusion process, then the helium begins to fuse into something else. You might remember the periodic table, that nasty table that you saw in high school biology, maybe in chemistry. Well, that periodic table of the elements is a very important table for us astronomers, because that is really telling us all of the chemistry of the universe. Everything you are made of, every single thing you're made of, everyone watching, was made in the heart of a star at one point or another. Hard to believe, but we are made of that material. And my favorite astronomer, Carl Sagan, used to say, I'll do it as best I can, we are made of star stuff. And star stuff was what I remember, because as a kid, I remember hearing him say that. And we are made of star stuff. We're made of the materials forged in the hearts of stars. billions of years ago, those stars, when they get to the position of the upper right here in this diagram, they have gone through much of the, they went through all their hydrogen, then they went through the helium. Then if you look at the periodic table, it goes into carbon and nitrogen, oxygen, and all these other materials up to iron. Iron is number 26 in the table. Who cares about the number? All you have to understand is that number is where it stops. Stars don't make any more elements beyond that in copious amounts, except through other, and there's other processes that fill in many parts of the rest of the table. But when a star gets to iron, especially a big massive star, 10 times the mass of our sun or beyond, then that iron is like something stuck in its throat. And when the final fusion products are no longer available, the star collapses. And that collapse of that core of the star happens in, no lie, a quarter of a second. And in that quarter of a second, a lot goes on. Very, very high pressures hit the center of the core, the star that's hitting from all sides. So that just goes down onto something you can't move and can't crush anymore. And then it just bounces off. And that bounce reverberates through the entire rest of the whole star, blowing it to pieces. And that is what we call the supernova. And the supernovas are responsible for scattering the star's guts to the interstellar medium, right? And those guts, those chemicals, those elements that we see in our periodic table scattered throughout the universe are what end up making planets eventually, or what end up making other stars. And hydrogen is the most stars, so hydrogen will be made into a star, and then the star will be made with sometimes hydrogen, the helium, oxygen, neon, calcium, and all these other elements that were previously made in other stars. The star will have in its atmosphere, just churning around for the whole life of its star, and not doing anything with it. Pretty impressive, pretty cool how this works. And so we have these giant stars that use up their hydrogen, and we have the really, really small stars down here, these low in the right corner there. You see those, the little ones, those little tiniest ones are called the M-type stars. M stars are the most popular star in the universe. The universe loves them. There's more of those than any other kind. And guess what? There's more planets around those types of stars than any other kind. So if we're going to go somewhere eventually when our sun becomes one of these red giants up here, and it will once it runs out of hydrogen and starts to swell and bloat when it starts burning and fusing other things, then we're going to have to find a new home. Don't worry, that's about 5 billion years. So you don't have to plan now, but you do have to plan someday. I mean, we will as a people have to plan someday. So anyway, that said, as we look at the sky, what does this all mean for us? Here is the constellation of Orion. I shot this photo out in Arizona at our new Sky Tour live stream site. And this is a beautiful shot. Believe it or not, this was only about a 15-second exposure. Look how many stars are around Orion. Here in Connecticut, we don't really see that many stars around Orion, do we? We see Orion. We see the belt of 3 stars right there in the center. We see in the upper left, we see that beautiful orange star, which is supposedly the brightest star in Orion. I'll tell you why it's supposed. And down the lower right, we see the supposedly second brightest star in Orion. That's Rigel. This star in the upper left is called Betelgeuse. And to the right, we have a star called Bellatrix. Down at the lower left, we have one called Saiph. And then in order, this one here, the one on the left side of the belt, that's called Alnitak. And this is Alnilam next, and then Mintaka at the upper right of the belt. And down below all that is a beautiful nebula, a stellar nursery where stars are being born. And so Orion is a very popular constellation. When someone gets a telescope, the first thing they look at, if they can, if Orion's up, is the Orion Nebula, which is this beautiful red object down here. So the Orion Nebula is gorgeous. And if you look at the stars, if you are doing it from an astronomical point of view, then the first thing you notice is that Betelgeuse comes from this upper right part of the diagram. And you can see that on the diagram. The arrow points to where it comes from. It is a supergiant. If you put Betelgeuse where the sun was, literally put it in place the sun, it would go out beyond the orbit of Mars in diameter. Okay, it would go out beyond the orbit of Mars. That's on either side of that location. So stars can be massive, massive. In fact, the size of the core that actually does the fusion in Betelgeuse could very well be as big as some stars that we see, just the core. So that's incredible, and that's Betelgeuse, and it's when it goes, it's going to go into a supernova, all right, and that's what we see here. This is what a supernova looks like, and we'll see, we'll expect to see that Betelgeuse might actually become a supernova like this someday, because it's definitely uh, it's definitely on its way. You know that it's dimming. It has been dimming. It's going back now. And you think maybe there's some dust or something, or a gigantic bubble of material coming off Betelgeuse. Because Betelgeuse being a red giant, it makes these gigantic bubbles which pop off of this thing. Okay, lots of mass in there. And then those just sort of drift away. And if they happen to be in our line of sight like this, well, this material is getting cooler. And as it does, it's going to make Betelgeuse back here, roiling and boiling and being bright. It's going to make it look dimmer. So then when this gets away, or when it dissipates, then Betelgeuse comes back to its brightness as seen from here. Again, if it's in our line of sight. So that said, this is what we might expect from Betelgeuse someday. And just between you and I'm really hoping that's the case. I would love to watch Betelgeuse explode into a supernova. I would love to see that happen. Because all that material, it would make a beautiful supernova. We'd see an expanding, we'd actually see the expansion of the supernova from here, because Betelgeuse might only be between 500 and 700 light years away from us. And the latest research shows that Betelgeuse is actually a little closer than we thought, and a little smaller than we thought. So as you can see, astronomy isn't an exact science everywhere. In some places it is, but in some cases it's not. And this is one of those cases. So we saw then what Betelgeuse looks like. Down here in the lower right, we have Rigel. And you see Rigel comes from that area on the diagram. Oops, sorry. Rigel comes from that area on the diagram. So it's a giant star. You can see that there are giants. And Rigel is finished fusing its hydrogen into helium, because all stars do that first. All stars do that first. Then when they move off and start fusing other elements, well, that gives them new energy and they swell. And that's what we're seeing here, right? So Rigel's there. All right, now, next, I kind of gave you a little preview before. This is Alnitak. It's one of the leftmost stars, and it is the leftmost star in Orion's belt, which you see right down there. And it comes from the far left upper area of the diagram, one of the biggest, one of the brightest, one of the hottest stars in the universe, right? It's an O-type star that's, again, hot and blue. Most of its light is in the radiation level in the ultraviolet, and it's massive. And when Alnitak here dies, it's going to go into supernova. Now, Alnitak's only a few million years old. In fact, it's so young that when Lucy, Australopithecus afarensis, was wandering around Olduvai Gorge in Africa 4.2 million years ago, Orion didn't look like this. Orion didn't have a belt of 3 stars. Alnitak wasn't there. Alnitak was born after Lucy. How about that? So that's pretty interesting to think about, So we have, we have studies of stars that we do that show us their age, their distance, and all that. And none of these stars are close enough to ever cause us any harm should they go supernova. And all the stars we're seeing here, Betelgeuse up in the upper left, that's going to go supernova. Bellatrix, the one to the upper right that I'm just briefly revealing, that's going to go supernova. Alnitak is going to go supernova. Alnilam, the middle star here, supernova. Mintaka, supernova, eventually. Saif down here, maybe supernova, maybe not. And then Rigel, definitely supernova. So you see, all these stars, which are relatively close, we're in the same region of the galaxy. If you think of the galaxy as a big spinning disk of stars, well, there's one little area called the Orion Spur, and that spur is where we are, right? And so that's why the stars are so bright from Orion, because that little spur is sticking out, and we're kind of just below, tooling around the galaxy, kind of with it, all right? So that's what's going to happen eventually, is that those are all going to go away. And so Orion won't be Orion anymore, will it? Actually, it'll be a sight in the sky. There'll just be a bunch of nebula, a bunch of these beautiful nebulae, all supernova remnants, and some of them will be probably visible maybe with your naked eye, with your eye without seeing anything, maybe Betelgeuse, because it's not, it's the closest one. So that's possible that we'll see it. But when a supernova happens, you can't miss it. In Sky Tour live stream, our live observatory that we do on clear nights, we have our observatory here in Connecticut, and we just finished building the observatory in the Sonoran Desert in Arizona. And on Tuesday, the final touches get done, and then equipment goes in. And we're going to be doing live broadcasts from the desert, as we do here in Connecticut, from Connecticut, with our live observatory. It's on YouTube. It's free. But when we look at these stars and look at these locations in Sky Tour live stream, we can see all these remnants of supernovas, remnants of stars that have obliterated themselves since they've faded into obscurity. We can see them very clearly, and we show them to everybody. Now, when a supernova first happens, it's the brightest thing in the sky. Chinese astronomers in 1054 AD saw that there was a new star in the sky. It was in the constellation of Taurus, the winter constellation for us. And it was a little bit to the left of the Eye of the Bull, which is the red star Aldebaran. And what they noticed was that this star was visible at night, okay? And then it was also visible during the day, some months later. During the day. How about that? So through the blue sky, they could actually see there was a star. That was a star blowing itself to smithereens. So that brightness is the result of the star's supernova process, right? It's just hugely bright, massive. And when it goes off like that, for months and months, that star can stay really, really bright, that remnant. And as it expands out, it begins to cool and it dims over time, right? And then you have a remnant. Now, right now, the remnant in that location where Chinese astronomers saw this new star, that remnant is called the Crab Nebula. And if you look that up online, the Crab Nebula, you can see how the Crab Nebula looks right now. It didn't look like that to the Chinese astronomers because they saw it in 1054 AD when it was just a bright star. But over the last 100 years of people taking pictures of the Crab Nebula, we can actually see this. We see from the late 1800s, we see this, then we see this and this and this. It's actually expanding outward. And in all the successive photos, you can actually see a little movie that they've made. If you look up Crab Nebula expansion, you'll see the movie. And it's really cool to see how it's changed over the last 100 years. Now, because it's far away, okay, I think that it stands to reason that it's going to take a longer time to be noticeable to us here. But that's okay. So the stars are fascinating. The way they end their existence is fascinating. The supernova is fascinating. And then there's a calmer way they go, the way of a lower mass star like our sun. And those stars are just going to bloat into red giants after they use up all their hydrogen and go again off the Hertz Sprung Russell diagram to one of those red balls you see up above there. Okay. And then after they fuse all the elements they can, they're not going to explode in a supernova. We're not going to. And when it runs out of the rest of that final fuel, instead of a catastrophic collapse, it just slowly tapers off. It slowly shrinks down, and it goes to something that you see down below the chart in the little white dots. Those are the white dwarfs. Okay. The white dwarf is the end state of normal stars like the sun. Okay. And when that happens, that thing goes down to about the size of the planet Earth. That's what's left. It gets really, really compressed and it's really, really hot. It gives off most of its energy in the ultraviolet and causes nebulas to glow around it when it expels all the gas that used to be in that star's body that gets expelled off. And the white dwarf is the only thing left. It's the hot core left over the star that's collapsed into a white dwarf. So stars are fascinating. If you want to talk about stars, you can join me on Sky Tour Radio on Sunday nights from 8 to 10 on kgraradio.com. We're a very popular astronomy show. We reach a few million every month, a few million people, and we have a lot of people that join us from all over the world and like to hear our radio show. And if you have questions, you can also address them to us as well. In the chat, we have a live chat. We have a co-host or two, and they'll be able to take your questions as well. So that said, now that you've known about the stars, let's talk about what we see when we look up and we're not looking at stars. What else do we see in the sky? Well, we see aircraft, of course, and these, we know what they look like in the sky when we see them with our eye. You know, a little blink going by, and say, "Oh, okay, that's an aircraft with its strobe lights going." You know, and if you really knew what you were doing, you would say, "Ah, they're blinking at 60 cycles, which means, you know, one blink a second approximately. Those are the wingtip strobes." You know, and sometimes it goes like this, with this does two, but it does it in a pattern of 60 cycles, which is the FAA mandated array. And you'll know that the bottom light is red, okay, and it may just glow intensely and then stop, or it may just blink, you know. And you'll know that there's lights that are always on. When you're flying a plane, you know that there's wingtip lights that you always see that are on, especially when you're flying through clouds. You see, oh, there's lights on, you know, that you might not be able to see from inside the plane. So that's pretty interesting, okay? You understand those. But the thing that's interesting about these is that when you take a picture of them, a time exposure, then they look like this, okay? You can see those flashing strobes I told you about. Those are the two parallel white dots next to each other. And those happen one set of flashes per second. So in this picture, you can see that there's 1, 2, 3, 4, 5, 6 flashes, and we're just missing another one. So this photo was probably about 6.5 seconds long. So you can tell things because the flashes are at 1 second intervals. So you can just count up the flashes and say, oh, well, that had time to register. Then those white lights, that are those lights we always talk about, that I was just telling you about, that are on all the time, well, they're constant on, so they make a trail. And that belly strobe that flashes, the one I told you about, the red one, they call that a Mars beacon, but yeah, you know, that one also, you can see that it has 1, 2, 3, 4, 5, but that is offset in the way it blinks. So we're just missing it on this far left side, and it's just after the strobes here. So we're just basically missing it. We're missing a little section because the exposure wasn't quite long enough. If it was 7 seconds, we would have seen it. But this is what an airplane looks like in the sky when you take a time exposure. I received so many of those that people say, look, this is how I saw it with my eye in the sky. Because people sometimes can't remember what they saw. And they will often say, well, I think I saw it this way. And then they'll convince themselves they did. Yeah, I did see it this way. This is what I saw. It was a line moving through the sky, just like that. And when we look at it, we know that that's not what they saw. They're not liars. They're just remembering in a different way than it actually happened. And that's okay. We're human. We do that. So when I look at this, I say, hey, that's pretty interesting. But I do know that it's probably not, and definitely not, you know, something that's extraterrestrial, unfortunately. Okay, I can promise that. You know, so, but that's how it goes, you know. I love the cases. I love doing this. So if we go on again now, this is what I just finished telling you about. And I'll give you a moment to read that if you like. Okay, the FAA guidelines dictate a certain flash rate and flash sequence and colors and all that. And that's what this all means, okay? And when we talk about the way that aircraft are lit and the way that they do their thing, clearly it's important to understand that if it looks like a duck and it quacks like a duck, it's probably a duck. I had one person who routinely told me that the airplane photos that were being taken were not aircraft, but objects that were pretending to be aircraft. Yeah, I know. Look, even if that person was right, how could we tell? There's possibly a way. And some of you that know me know I work with Douglas Trumbull. He's the Academy Award winning visual effects guy. Doug and I are very good friends. We're working on a movie about Nikola Tesla right now. And that that man is a genius. And we are doing a UFO hunting system together. And that UFO hunting system is going to use some science, okay, that I have to bring to the table, that's going to be able to differentiate between, say, an ordinary aircraft and a disguised aircraft. Because a disguised aircraft would be giving out different radiation if it was actually some type of alien craft. And that different radiation is something that we would be hunting for. Okay. So that said, you know, we know that there's aircraft, and we can figure out the difference between them. But in the night sky, also, we have meteors. Now, how many have seen a meteor? 1, 2, 3. Yeah, I can't see your hands, obviously. How many actually raised their hand though when they said that? Just be fair, be honest. You know, someone went, "Oh God, I raised my hand." You know, but the truth is, when we look at meteors in the sky, sometimes meteors are like just bright flashes, and they're gone. But see, the Earth's rotating, and as the Earth rotates, if the Earth is rotating, okay, rotates counterclockwise as seen from the top. So as the Earth rotates, then as the meteors are rotating, as we're moving through orbit this way, and the Earth's rotating this way, then, by the way, if my camera's backwards, I apologize. Let me actually check. Yeah, okay. You're probably seeing it right then, okay? Because on my video, it's not working right but anyway. So as the Earth's rotating this way, as it goes around the sun, orbiting the sun, then meteors come in this way. They're catching up to the Earth as it goes, right? They're catching up to the Earth, and as it becomes night, then they're going to enter the Earth's atmosphere more slowly. Okay. And you might see a slow moving meteor come in. That's when you see them. It's after midnight because they were after that midpoint. Here, this is midnight. Here's the sun out here. I'm the sun. Ta-da. Okay. And the other side is midnight, right? So if you're rotating when you get past midnight here, okay, then these meteors that come in are going to be, just about midnight, they're going to be catching up to the Earth, and they'll tend to be slower. But on this side now, on the other side of midnight, when we're approaching the early morning, now we're moving this way, and the meteors are going to be fast and furious and coming at much faster rates. And that's something that we have to consider as well. So they look different. They look different. And we also see satellites in the night sky. Sorry, water break. I've been talking nonstop for, I don't know, a whole bunch of years. It's also my birthday today, so I'm like talking like crazy today. And we see satellites in the night sky as well. And I'll show you some more examples of those. Now, when we talk about other objects in the sky, we know that comets have long since influenced our culture. Comets can scare people. Comets can make people feel that their lives are about to come to an end. And when Camille Flammarion in the late 1800s talked about comets, that happened as well. And we'll get to Camille in a little while, but I won't spend too much time on him. Right? So let's go back to meteors. When you see a meteor, what color is it? Do you remember? It's elusive. Sometimes people see different color meteors. And when I look at a meteor, okay, you know, first of all, they're very high up, almost 100 miles. And when you talk about the colors they can be, then here's what we're looking at. If there's a meteor that comes in and it has any kind of a nitrogen and oxygen component to its compounds that are in its crustal makeup, then the meteor might look red. Those are somewhat rare. Most of the time, the meteors are going to be yellow, all right? And that is because they have iron in them, okay? And actually, I know this is going to violate things, but I'm going to show you something. So don't go away. Don't move. I'll be right there. Here I am. I'm coming back. Okay, I have it now. I had something to show you. Okay. All right. So this is what we're talking about here. If you can see my video, this right here, this is an iron meteorite. And I don't know if I'm assuming my video's playing or you can see it, but I'll try and get close. If it is playing, you can see it. I'm showing you an iron meteorite. It weighs over 1,000 grams. It's actually pretty heavy to hold out here for a while. But this guy, when it came in, it was a lot bigger. And as it burned, it left that yellow, like you see in the iron one over there. It left a yellow trail behind. All right. So it was yellow. Okay. Now, if there was a stony meteorite or a meteorite that was made of a different material, then you might see a purpley looking color because it had some calcium in it. Or if it's an orangey yellow, then it could have had sodium compounds in it. All right? And magnesium, of course, you've seen magnesium burning. If you ever saw a transformer melt down, there's some magnesium in the transformers and you see them bright purple. You can't even look at it. Well, that's the magnesium going right there. So you see, this is something that is expected. So when you're looking for meteors, it's a lot of fun to look at the colors. And there's something else you can do with meteors as well, which is really cool. You can actually listen to them. That's right. There is a website where you can go listen. You have to look it up on Google. I think it's livemeteors.com. And you actually can hear what happens when meteors enter the atmosphere. They're ionizing the air ahead of them. And for a brief period of time, there is a trail behind them that they all make. And that trail could be visible or invisible. However, it's opaque to radio transmissions that might be on the ground. So if there's a big station still transmitting from big antennas, like some do, you can actually point an antenna from your house toward this distant station in the, which is over the horizon even maybe. And a meteor goes up over here, everybody's over here, and when the signal from the meteor, when that trail reflects some of the radio signal from this distant radio station, and it comes down to your transmitter and you listen to it, you actually hear the meteors enter the Earth's atmosphere. And it sounds like this. It's really cool how it sounds. So that's fun to listen to and to take part in. I was listening to some meteors. I saw 3 yesterday on a strip chart thing I was looking at from an observatory that's like around the world. So it's live online. You can go listen and watch. It's a lot of fun. So meteors are just crazy. Okay. Now, as we said, they can be a fast streak or be persistent, and those persistent trails sometimes stick around for quite a while. Okay, here, this is a meteor that was in Chelyabinsk, Russia, back in 2013. It entered the Earth's atmosphere, and it left a trail. And for the people that were underneath it, that trail was giant in the sky. And then when it exploded, it was like when it comes in, when a meteor like this races into the atmosphere and strikes the atmosphere at high speed, okay, that meteor is going to hit a wall at some point. It's moving thousands of kilometers an hour, tens of thousands, maybe 25,000 kilometers per hour. That's fast for those that don't know. And when it hits the atmosphere, it's going through a lot of the atmosphere very quickly. That atmosphere will build up very, very fast, and it'll start to melt away stuff as it's hitting. But then it gets to the point where it just can't structurally stay intact. And when that happens, the meteor will literally explode. And sometimes there's a sound. And when there's a sound, we call those bolides, B-O-L-I-D-E. And the bolide, this was clearly a bolide, all right? But it was a big bolide, okay? It came in, and when it exploded over Chelyabinsk, it actually caused over 1,000 people to have to get hospitalized because of the damage, flying glass. I literally saw, and that's the nice thing about Russia. They have a lot of security cameras, a lot of dash cams. You saw this thing come in, and it was amazing. Look that up. And you don't remember Chelyabinsk, just say Russian meteor video, and you'll capture and see tons of these videos. That's impressive. And now, when this came in, it literally blew steel security doors inward like this, and just like that, it crumpled them in. Garages blown right off, boom, and just blown inward, hitting people. The shock wave, when it exploded, was massive, and that's what does the damage, and we call that the air blast, and that is something that can really, really be damaging. So meteors are a potential danger to us, and yeah, it's a very dramatic universe. Now, meteors don't have to just be confined to the Earth. We were doing a Sky Tour live stream back on January of 2019, and at 11:41 and 35 seconds, this white spot appeared on the moon. This was a lunar eclipse. If you notice, the moon is nice and beautiful and blood red in the lower left, and just about the height of this eclipse, a little ahead, and we saw this white spot appear. We had over 5,000 people watching at the same time, so we had a lot of people go, "What was that?" It turns out that we are and were one of 5 groups on the planet, only 5 groups on the planet that actually saw a meteor strike the moon right at the height of a lunar eclipse. This is historical. This is historic. And we loved it. It was really, really cool. So, and that's example of kind of how we did things. We have these dome cams. People can see inside the dome. There's me down the little control room area. Okay. And then we saw the live view here. I was like, wow, this was really crazy. So meteors aren't just for Earth, let me tell you. Okay. Then we have satellites and we have comets. Now, satellites are interesting, okay, because they're really somewhat slow moving. And I went out over the last few nights when it was clear, and I just go out at the right time, and boom, there comes the International Space Station. It moves about this fast through the sky. Okay. When it gets overhead, it looks like it's going faster, okay, but it's not changing its speed. It's just it's coming toward us from a distance, so it looks like it's approaching. So you're not seeing it moving like this. You're seeing it coming towards you, so it looks like it's moving slower. Then as it gets overhead, it moves as fast as it can, as fast as it will appear. And then as it goes further away, it's going into the distance, so it looks like it's slowing down again. So it looks like they go slow, speed up, and slow down, right? And it's only 252 miles up. And it's bright yellow. You can't miss it. And I'm sure some of you out there have seen it. Who's seen it? I caught you. Okay. Yeah. So clearly, satellites are a lot of fun, and some can be very bright and some can be very dim, you know. Um, so when people say they've seen a UFO, sometimes they say, I know it wasn't a satellite. How do you know? Because it was three in a row. There were like a triangle moving through the sky. I saw this triangle of three objects. It definitely was a UFO, or a bunch of UFOs, a fleet of UFOs. I hate to say it, but you know what? That's not good enough, unfortunately. You know why? They could be right, but look, unfortunately, there are special satellite groups that are really put up there as triplets, as three triangular, orientations, so they can do special ranging missions down to the ground. So I'm sorry, that does happen. We do have satellites up there like that. So it depends on the mission, but I'm not trying to say that they were wrong. I don't take that away at all. I say you could be right, but we do know we do have triplets up there and doubles and triples up there. It's really true. The thing about satellites is, yes, they do not twinkle. They don't twinkle. They're solid, steady lights. They're not aircraft, because aircraft have the FAA mandated blinking lights. Even the military ones have to use them. Although I say that, and I just lied to you. I didn't mean to. But I watched an aerial refueling operation from right here in Terryville, Connecticut, where I'm located. And when I looked up in the sky, I saw this strange pattern of lights moving through the sky. I recognize it as an aerial refueler because I recognize what those look like. Okay, I've seen those before. And when I saw that, I said, they're not using the FAA recognition lights. They're not using FAA navigation lights. There was no red. There was no green. There's no strobes at all. And I realized, aerial refueler. Those strobes at altitude can blind the pilots. So they actually take and probably have a shield that prevents that strobe from going back, or they just shut the strobes off temporarily while the aircraft is approaching to refuel. Interesting. So I thought that was pretty amazing. So they don't twinkle either, but they are definitely aircraft, So, in photographs we look at, satellites look like this. This is what a satellite looks like. This is a time exposure. If it was say a 30th of a second, then you would say, oh, that's a meteor. It almost could be, except meteors have a bright spot where they actually, where they burst and break when they hit that wall of the atmosphere, like I talked about. Okay, but this is what it looks like. This is something called an Iridium Flasher. These no longer happen because the Iridium satellites have been deorbited and discharged from service. Okay, but satellites can look like this too. They can make these short little paths. You can see how it gets at the end of it, the right end, the upper right end. It's very, very faint. Then it gets brighter and brighter and brighter, and then it starts to taper again. That's an Iridium Flasher. Okay, now when we talk about comets, some of you in this previous shot might have noticed this little fuzzy thing down here and didn't know what it was. Okay, that's actually a comet. Okay, and comets are very cool, and they're kind of rare. We don't see them. I mean, they're in the sky every single night, actually, all year round. There's comets in the sky. They're just very faint because they're far away from the sun and not doing what this one's doing. This is Comet Holmes, by the way, Holmes, Comet Holmes. What they're doing here is the sun's heating them up, and they're beginning to outgas and put material off. And you might be familiar, and some of you are thinking, I can hear it, I can hear it. You're thinking about Comet Neowise, which just came through. And this is Comet Neowise, okay? You'll notice it doesn't seem to be moving, but in fact it is. If you look down the bottom of the screen, when this is a replaying GIF over and over that I made, this is one night over 45 minutes, okay? See these little two stars down the bottom? Look at how the comet's moving away from those in 45 minutes. You're watching the comet move through the sky. At the same time, we're actually seeing, okay, two satellites go through, one on the upper left and then one on the upper right. Watch again. Okay, there's the one and there's the other. These are time exposures that I put together into a little movie. And you'll notice that the tail of the comet doesn't look like it's changing much. And that's because this is millions of miles long. And to see the change, it has to be somewhat dramatic. And as the comet was setting that night, you can see the trees coming up into the view. So this is Comet Neowise, Neowise. And NEO stands for Near Earth Object, right? And the WISE part is the Wide Angle Infrared Survey Explorer. Okay, that's NEOWISE. And WISE was the original satellite, and it became NEOWISE when it started looking at nearby objects, okay? And you can see that comets have two tails. This is what's called the dust tail. It's the gossamer tail that trails off behind the comet as it moves through space. But then you have this blue one here. This blue one is a chemical reaction. It's a reaction caused by ions in the comet that are driven off by the solar wind. So the sun is obviously in the opposite direction of that tail, down past the comet's head, down below the picture. Okay, so clearly comets are a really interesting and very strange object that we see. We've been to comets. We went to with the Rosetta mission, we went to Comet Churyumov-Gerasimenko, which was 67P. We saw some beautiful images of Comet 67P. So, but they're very special and they're very amazing to look at. Now, I promised you toys, and I'm not going to give up on that, and I'm not giving up on you. We talk about toys. What do you want to put on your iPhone? What kinds of tools do you want to use to look at stuff on your iPhone about space? Well, there's a number of them. I can't recommend enough SkyGuide. I have SkyGuide on my phone. In fact, that's an image of my phone you're looking at right there. And SkyGuide is really, really impressive. You can zoom in, pinch zoom, and see stuff. You can hold up your phone and it will show you what's in the sky. And as you move your phone around, it's augmented reality. It moves to what you're looking at and tells you what it is. I can't tell you enough that this is worth every bit of the zero that you have to pay for it. It might be $2 or $3 now, but you know something? It's worth every penny. Every penny. You can put it, once you download it, you can put it on an iPad, you can put it on your iPhone, and you can it'll always be available to you. Okay, now, if you zoom in, here's Orion. Check that out. You see the nebulae in Orion? Look at here. This is Alnitak, Alnilam, and Mintaka. It tells you what things are. What the Horsehead Nebula. We talk about the Orion Nebula. There it is, right there. You can see it really clearly in the lower right. You know, it's beautiful, and it shows you the constellation lines, and then it shows you the stars, and they are the real thing. So this is really worth every penny. SkyGuide, don't forget it. It's beautiful. Write this down. Come on, yeah, you in the front row. You didn't write it. Come on. I know. I'm milking that one. So that's SkyGuide. Now, if you want to look at the satellites we talked about, well, then this is the other one. GoSat Watch. I recommend you take pictures of the screens with your phones, by the way, so you can remember these things, okay? And just quickly, I'll just go back here quick. Get your phones, take a photograph of the screen so you have SkyGuide and you see what you're going to get, okay? I'll give you 10 seconds. Ding, 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 ding. It's still your turn. Okay, and then I'll go on because I want to make sure you capture these if you're going to do that. Just take pictures with your phones. Okay, I'm moving on now. Here we go. 3, 2, 1. Okay. So take a picture of this screen if you haven't already. This is GoSat Watch. GoSat Watch is amazing because it will show you the night sky at a glance. Right? You hold that up and it shows you where all the satellites are. It'll send you alerts. It'll tell you when the ISS is going over. You know, we've got millions of pieces of space junk up there. And we have hundreds of visible satellites. And we have thousands of some satellites that are slightly less than visible. and hundreds of thousands of satellites that are spent rocket bodies, you know, the second stage of a rocket that didn't quite, you know, get dealt with. So it's in a far orbit and orbiting. So we got a lot of junk around the planet, you know. And now we have Starlink satellites as well. Now, for those that think Starlink's a really, really bad thing, I'm an astronomer and I also understand that that's true. But guess what? Starlink is why Skytour Livestream West is actually going to work, because we're going to use Starlink satellites to broadcast on the internet. And it has 100 megabits per second download speed and a 40 megabits per second upload, which is way more than we get even here in Connecticut. So don't worry about the numbers so much, but just understand that it's a very fast internet. So that's something that's going to actually work for us. And I rail against Starlink because of what it does to the night sky. Yes, I caught them in my views and it's like, I got to throw that one away. Starlink satellite went right through the middle of the nebula. But, you know, we just have to make sure we do this when the satellites aren't around, you know. So GoSat Watch is one to look at. Here's an example of what the passes look like here. Okay, this here is a SL16. Okay, that's the designation for this, and the RB means rocket booster. So this is just like junk, all right? And this is the Meteor Piroda. I think that's a Russian weather satellite. And then we have N-Just-1 and Cosmos, another Russian satellite, the Ariane rocket booster. And then the Iridium, that's an Iridium one. Okay, and it tells you everything about it. If you click on it, it'll show you where it's going to go over in the sky and where it's going to be, and gives you all the information you need. And they can set alerts, say, hey, show me that when it's coming here. Give me a 5-minute warning or whatever. And it does. You'll have a little ping on your phone. You go, oh, ooh, got to run outside to watch the Iridium. You go outside, you look up, and there it goes. You know, it's great. Just amazing. So that's GoSat Watch. Then if you want to know where to look at dark sky, this is how you do it. Okay. Dark sky is an application that allows you to look at the night sky and see where the light pollution is going to be. There is Skytour Livestream West, just out in the purple fringe into the dark. We have a very nice site out there in Arizona. Okay, so dark sky is that one. Hope you have your cameras ready because I'm moving on. Right, and this is another example. So Phoenix and Mesa. This is Phoenix here, obviously white, and that's what we call the Bortle scale. It goes from 9, really, really bright, all the way down to 1, which is outside the range here. But this is less and less and less light pollution. Here where I am, we have this greenish orange. So we have Milky Way, but it's pretty bad. And then if you want to know about the moon, Moon Globe HD, you can't beat it. Moon Globe HD allows you to see what's going on in the moon. You can spin the globe around, see it like a telescope sees it. It's really fun. You can see where the landing sites are for the Apollos, which we actually went to the moon. Yes, we did. Okay. And it's really phenomenal. All right. So Moon Globe HD is another one that's got to be on your must-have list. All right. And then if you want to know about the planets around other stars, which is my specialty, then you can go to Exoplanet. Hanno Rain wrote this application. He uses the public database on exoplanets. He put it into an iPhone app. Really, really good. And you can learn all about the planets and see what they look like compared to the Earth. As you can see in that second panel, shows you how they made them up above, where they are in the night sky, and where they are placed around the star. Are they in the habitable region, or are they not in the habitable region? Just excellent application. So that is what we do. Now for public outreach, Skytour Livestream is our nightly foray. Like I told you, that's the actual observatory with our telescopes here in Connecticut, in Terryville. You can find us on YouTube. We're on Facebook and the Skytour Livestream group there. We're on Astro Imaging Live with P&K Space Imaging and with Bill New York Skywatcher. The three of us, the happy triumvirate. Sometimes we're all streaming at the same time, and you can just click and go into each of our streams. It's really kind of cool. All right. So we have a bunch of greatest hits that we can run through, and I know I'm running out of time here, and I want to thank Aurelio for the time to do this. But we have had an awful lot of good stuff here. And we can do things not on par with space telescopes, but we can give you a pleasing alternative to the space telescope world. But just to give you an idea how space telescopes see things, this is the best photo of the Horsehead Nebula in Orion, and this is how it looks with the Hubble Space Telescope. Wow. This is the Sombrero Galaxy. This is how it looks with the Hubble. With a little close up, you can see just how beautiful that is. I know I'm going fast. This is the Whirlpool Galaxy, one of the best photos taken here. And this is how it looks with the Hubble. I mean, look at that. Wow. Every one of those red areas is a stellar nursery where stars and possibly planets are being born. And this is the Crab Nebula taken here with the SkyTour live stream, the one I told you about. And this is how it looks in the Hubble Space Telescope. I mean, amazing. We took this, the Lagoon Nebula. Here, it's a summer constellation. This is how it looks to the Hubble Space Telescope. Real detail. So there you go. That's it, man. I know I compressed an hour and a half into an hour. So I did as good as I could, Aurelio, without speaking, too quickly and like talking like that Micro Machines guy. When the Micro Machines kind of I'm going to do all that. I can't do that any time soon. But I hope that's okay. And if anyone has questions, I know you're taking a break, but if anyone wants to stick around for questions, I'm free to answer any questions if you got them. I know it's a little overwhelming.